Purpose family. Um, God is good this morning. It's a beautiful morning where I'm at. The sun is beautifully up there shining. Um, Nice cool weather here too. I wonder how it is where you are. Um, where I am at, pretty nice. How is it where you are today? All right, good to know. All right, so today we are looking on gradient. So gradient is that big name for slope. A slope can still be considered to be a big name. So let's see if we can get some clarity on these words quickly. So gradient of straight line is our topic, and gradient, let's first give a definition for this. Gradient is an inclined part of a road or hill or railway. Another word for this is to say slope. Slope is something that we are familiar with too, because we, in terms of seeing it in the environment, can talk about the slopes of road, slopes of roofs, slopes of hills, and so on. So this is something that we would have been seeing in our environment. Some other words that we might be using that we may not know that we are really talking about gradient. So let me tell you what slope is. Slope, a surface of which one end or side is at a higher level than another. So a surface of which one end or side is higher than another. You may be using this word gradient, slope, but not knowing that you're using it, because you may be saying slant. Now, slant is something that is more popular. Somebody would say that is slant. It's not, straight or flat. It's slant. So slope or lean in a particular direction can be considered also to be a slant. And you have other ways to talk about it: incline, tilt, so on. Or sometimes you hear a person talk about the thing or the broom lean up on the wall or lean the ladder on the wall. So these are some more familiar terms. Same, gradient, slope, slant, incline, so on. Tilt, all of those words are the same. Now, we are speaking about slope specifically of straight lines. And you would have an experience, I'm sure, in your life at one point of climbing an hill. So you must have climbed a hill in some point. Maybe some persons are climbing hills now. If you are on Highway 2000, going out there to Ocho Rios, or heading out to Montego Bay, and you're on Highway 2000, you would have to climb some hills. And also, you'd have to go down some hills. So you're talking about gradients there as well. You would also see at various points signposts that will tell you the percentage of the incline. So that means how steep the incline is. If you see an incline that says it's 10% gradient or 10% incline or slope, you will understand that that is not as steep as seeing a signpost that says it's 25% gradient or 25% slope or incline. Normally you see this as a truck, and you see the truck on the road, and that's the incline. You have it also for going up, you have it for going down. So sometimes you're going up the hill, sometimes you're coming down the hill. So you have been seeing these things in your environment. It's not entirely new, but let's go back to you climbing an hill. All right, so when you're climbing a hill, two events happen. You are moving forward. If you're driving now, hearing me now, you're driving forward. Because you're driving forward, something else is happening. Two events are happening. And we want us to kind of pin down those two events. As you're moving forward, so that's one event, something is happening if you're going up a hill, right? Yes. What's happening as you move forward? Yes, you're going up. You're getting higher and higher and higher. You're rising up higher and higher. So therefore, as we are moving forward in this time, we are definitely elevating. We are getting closer and closer. And now, because the scripture says, when you shall see these signs, look up, for your redemption joy nigh. So you're familiar with what we're talking about this morning. All right, so let's talk about it a little bit more. So I am here on Google, And basically, I have just typed in gradient, looking on different types of gradients. So I want to see different types of gradients in the environment that you have been familiar with or looked on. So you have looked on a hill. Basically, you have numerous hills. Once there's a hill, once you start to go forward on the hill, you're going to experience, as you're going forward, you're also going up. So you're not going to be going forward and always just going forward. As you're going forward, a next event is happening, and that event is called a lift, or what is called a rise. So basically, forward movement, as you go forward, you are rising. You're getting higher and higher. And if you are going down the hill, which we have not spoken about going down hills yet, we want to leave that out to the end. But if you're going down the hill, then as you're going forward, you're seeing that you're going down. And so I'm looking on a staircase here. I'm on Google. I'm looking on staircases in terms of slope. There are slopes there. Looking also on the roof. I'm looking on hills here. Somebody sliding down a hill right here. So there's so many examples. Roller coaster, right? You could see that picture in your mind too. Yes, they are going up, and also events of going down. I'm looking on also this steep gradient here with somebody climbing up a steep hill. And now, of course, I just pointed the roof. I'm looking on driveways. All of these are indications of slopes in the environment. And there are so many of them. I mean, I could talk to you about, oh, this is a kid slide here, right? With also a slope in it. That's good. That's nice. So slopes are everywhere around us, right? So it's now just how we now apply this to the maths that we are teaching this morning. And I want you to follow me so far. You know. 2 events are happening if you're climbing a hill. What are the 2 events? Do you remember? Yes. Okay, yes, I hear. If you're moving forward, yes, and you're climbing a hill, what's happening? You're going up. Yeah, that's beautiful. So those are the 2 things that are happening. So once you talk about grading, as you move forward, you're also going up. Beautiful. So I'm so glad that you are with me on this, because being with me on this now, I'm good to go, because I know that you know those 2 events. You say that as we go forward, we are also going up. Beautiful. That's beautiful. All right, so let's continue then. So let's go back to the hill, just climbing a hill. If you're driving a car, that's all right. But if you're climbing it naturally, that's all right as well. 2 things you have to consider here. You have to figure out where the hill starts and where the hill ends, because this is definitely the hill don't continue up and up and up forever and ever and ever. So a hill starts at a point and it ends at a point. Same with an incline. Start at a point, ends at a point. So let's now introduce us to looking on the 2 things that I asked you to remember. Do you remember the 2 things I asked you to remember as you climb a hill? The 2 events that I asked you to remember? Okay, yes. As you move forward, so moving forward, that's one. We're also going to give a meaning now to moving forward. So moving forward, let's call that rise. So we're going to call moving forward. No, let's call that run. Sorry, my apology. As you move forward, that is your run. So we're going to call that run. As you move forward, that's your run. And as you move forward, another event is happening at the same time. So these 2 events are happening. As you move forward, you're also going up. Let's call going up rise. So as you move forward, that's run. And as you move forward, you're also going up. So let's call that rise. So now let's describe to you mathematically, because we're teaching maths this morning, a formula that will give us gradient. And the formula that gives gradient to start with is your formula rise over run. So gradient equal to rise over run. So when you move forward, how much do you rise? That's what this is all about. So remember which one goes at the top. Which one goes at the top? Rise goes at the top of the fraction, and then run goes in the denominator. So we are familiar with the numerators and denominators. Rise is at the top, run is in the denominator. So let's go quickly. We're almost done. It's activity time. Yes. And once you're going to get the activity, I'm just going to give you a quick example, and then we'll go right into the activity, right? All excited? Yes. Beautiful. So now, activity time. All right. So the example first before the activity is, what if you move forward 4 units. Unit just mean a portion of moving. One portion of moving forward. So let's say we go forward 4 units. And as we go forward 4 units, would have a rise of 3 units. What would that gradient look like? I'll tell you quickly. That gradient looks like rise is 3 and run is 4. So that's 3 over 4. 3 over 4. Remember, as we move forward, we went up how many? 3. So therefore, that gradient is 3 over 4. It means, therefore, that as you go across 4 units, you would go up 3 units. So therefore, every 4 units you go across, you would have gone up 3 units. So for every 4 you climb across, every 4 units you go across, you are going up 3. And then when you go across another 4, you're going up another 3. And when you go across another 4, you go up another 3. And I can do this all day. All right. So the gradient stays the same throughout the entire straight line. It means every time you go across 4, you have gone up 3. So the gradient there is 3 over 4, and I just described it for you. So now it's your time. I want you to set up for me the gradient that is moving forward by 2 and going up by 3. So you move forward by 2, go up by 3. What is that gradient? So that gradient equal to move forward by 2, you go up by 3. So what is that gradient? Which one comes at the top? Rise goes at the top. So what is rise? You went up 3. So that's 3. Yes, I'm getting you now. Good. And how many you went across? 2. Okay, right. So gradient equal to 3 over 2. Beautiful. You guys are doing excellent this morning. Excellent work. So you go up 3 as you go across 2. So every 2 you go forward, you have gone up 3. So your gradient is 3 over 2. 3 over 2. As you go across 2, you are going up 3. You go across 2 more, you have gone up 3. You go across 2 more, you have gone up 3. So the gradient is 3 over 2. And for all points on the line, that gradient is the same. The gradient is the same right throughout. Now, you did well. You did well. Let me just give you a big clap. Excellent work this morning. Excellent work. All right, so let me ask you now to do something for me. I need to take you to another level in terms of your thinking. So let's go. Please explain for me the gradient 2 over 5. Explain for me the gradient 2 over 5. What does that mean? If you climb a hill which has a gradient of 2 over 5, what does that really mean? All right. Yes. Okay. You're saying that all right. You know that bright students that always come out at the first point of the class and just tell you everything we need to hear. Yes, I think that's you. I heard you. I just wanted to see if anybody else could get it. All right. Okay. All right. Yes. All right. Good. Yes. Thanks for understanding. Yes. All right. I hear you. You see what? You see why we need to let other persons kind of share? Very important. Yes, because we know that other persons know, but it took a little while for the other person to pick it up. That's nice. So explaining the gradient of 2 over 5 as we come to the end. Yes. All right, good. So every 5 you move across as you climb this hill, we're still climbing the hill. So every 5 we move across, or every 5 we move forward, would have gone up by 2. Every 5 we move across would have gone up by 2. So yes, that's good. So we move across 5, we go up by 2. Then we move across 5 more, we go up by 2. And that is the slope for the entire line. All right, so that's good. I'd ask you. All right, good. So that's it. Next time we meet, we could look on start points and end points, right? Good.